I'm Spencer Holman.
I'm Keelan Swain.
I'm Terry Gilbert.
I'm Andrew Hood.
And I'm George Kimani.
Yeah.
And we are presenting on the ARM microprocessor.
Introduction to Advanced RISC Machine Microprocessor, or better yet known as ARM Microprocessor. It is one of the most important microprocessors today. It was designed by ARM Holdings plc. Now to the theory. ARM architecture is based on reduced instruction set computer architecture. Its features include a uniform register file load store architecture, where data processes operates only on register contents, not directly on memory contents. Simple addressing modes with all load store addresses determined from register contents and instruction fields only. Designed to perform a smaller number of types of computer instructions, hence can operate at higher speed, millions of instructions per second. It also has a low demand on power compared to CISC devices due to optimized pathways and reduced unneeded instruction. Because of the reduced instruction set, the ARM microprocessor requires fewer transistors, thus smaller die size for the integrated circuitry. The smaller size enables use in smartphones, tablets, mobile phones, and also wearables.
Beginning ARM design. Work on the development of the ARM began in 1983. Working samples were received in 1985. The team worked to create a chip which met the requirements of a processor which retained the ethos of the 6502 but in a 32-bit RISC environment. It was implemented in a small device to design and test easily, as well as fabricate cheaply. The important initial decisions were to use a fixed instruction length and a load store model.
The development of the ARM. After the launch of Archimedes, Acorn continued to support its research and development team in creating improved versions on the chip, offering greater performance. To expand the design so that it offered the kind of performance expected of a high-end personal computer or workstation, a 4 kilobyte on-chip data and instruction cache was added. And in 1989, the ARM was launched at a significantly increased clock rate of 25 megahertz. Acorn's desktop computers using this chip were launched in 1990.
Evolution of ARM. After designing ARM1 and programming the sample chips, the team learned that there were areas where the instruction set could be improved in order to maximize the performance of systems based around it. In particular, the multiply and accumulate instructions were added. The addition facilitated real-time digital signal processing, which was to be used to generate sounds. A coprocessor interface was also added to the ARM at this stage, which enabled the floating point accelerator and other coprocessors to be used. The later developed ARM2 still maintained its small die size and the ARM microcontroller. The ARM microcontroller (MCU) architecture has become the de facto standard for 32-bit microcontrollers, with its broad adoption of the embedded market and widespread support from software companies. Standardization on ARM microcontroller cores has now made it easier than ever to port from one 32-bit microcontroller to another. The deciding factor in MCU selection is the shift from CPU core architecture to the peripheral set and the innovative ways in which MCU vendors address system design issues.
Record something. So the ARM processor is great for smartphones and tablets. They have the hugest applications. This is because they're easy to use devices for everyone, so that has increased the demand on ARM. They're very useful applications so that to enhance people's life, and the devices allow technology to be implemented in their lives. So the ARM production percentages wise, 95% of ARM sales are for smartphone, 35% for digital television, 10% for mobile computers. The reason why smartphone influence the ARM industry in such a huge way is that they take away the key pieces of a desktop computer, like the internet, the mail, the camera, and document editing. The ARM industry is so implemented in people's lives. Like, it's at the point where devices, you can't leave home without your cell phone. And here we have a picture of smartphone sales trends. And so as the smartphone sales trends have increased, so has the demand on the production of ARMs.
Due to ARM processors' relatively low power usage and compact size, they are found in many technologies today, mainly in portable or compact versions of devices. One of the smallest fully working personal computers you can buy is the Raspberry Pi. This PC is about the size of a computer chip and has ports for various external devices computers need, like USB, memory, and display ports. The original Raspberry Pi used an ARM 1176JZFS 700 MHz processor, and according to the Raspberry Pi Sci-Fac, the ARM processor was chosen because of its overall cost effectiveness. Since the latest Best Pi model is only $35, everyone can now get hands-on experience with programming and actually see real results. The Raspberry Pi is allowing troves of people who may not have had access to a computer something to practice and learn programming with. In addition to that, many people have made programs optimized for the Pi that do most things a full desktop can do.
In conclusion, from being a single design aimed at a particular project, the ARM is now a set of highly customized processors and supporting macro cells suitable for the use in a wide range of applications, but targeted at systems requiring high performance from a compact device with low power consumption. The ARM.